Good morning, everyone. My name is Raj Patel from Array section. Today, my topic is a mathematical expression and variance continuous random variable. So, random variable. A random variable, usually written as a x, is a variable whose position values are numerical outcomes at a random phenomenon. There are two types of random variables: uh, discrete random variables and continuous variables. A variables is a something which can change its value. It may vary with different outcomes and experiments if the values of the variance depends upon outcome of the random experiments is a random variable. A random variable can take up real values. Here, mathematically, a random variable is a real valued function whose domain a sample phase of S and experiments of always be capital X, Y, Z. Introduction for random variables. We have discussed about continuous random variables. So far we have looked expected value, standard deviation, and variance for discrete random variable. Their summary statics have the same meanings continued random variables. The expected value mu is equal to E of x is a measure of location or central tendency. The standard deviation sigma is a measure of the spread or scale. The variation sigma is equal to a variance of x is the square of the standard deviation. What is the expected value for the continuous random variables? This summary statics have the same meanings for continuous random variable. The expected value mu is equal to E of x is a measure of a location or central tendency. The standard deviation sigma is a measure of the spread or scale. The variance of sigma square is equal to variance of x is the square of the standard deviation. Expected value of a continuous random variable. So we have this definition of the continuous random variable. Let x be a continuous random variable with range of close bracket ab and probability density function f of x. The expected value of x is defined by e of x is equal to integration a to b x into f of x dx. Then let's see how this compare with the formula for a discrete random variable. So e of x is equal to e of xip into xi. Here, the discrete formula says that take a weighted sum of the value xi of x, where the weights are the probability p of xi. Recall that f of x is the probability density. Its units are probability of unit of x. So f of x dx represented the probability that x is in initial range of width dx around x. Thus, we can interpret the formula for e of x as a weighted integrated value of x of x, where the weights are probability of f of x dx. As before, the expected value is also called the mean of average. Variance. Taking the mean as the center of the random variable's probability distribution, the variance is a measure of how much the probability mass is spread out around this center. We will start with the formal definition of variance and unpack its meaning. Definition. Definition of variance. If x is a random variable with mean of e of x is equal to mu, then variance x is a defined of variance of x is equal to e of x minus mu whole square. Let's rewrite our definition explanation as a sum. If takes value of x1, x2, x3, x4 up to xn with probability of mass function of p of xi, then variance of x is equal to e of x minus u whole square into x plus a raised to n. So that variance of x is equal to summation I equal to 1 to n p of xi minus mu whole square. In words, the formula for variance of x says to take a weighted average of the square distance to the mean. We make sure we are arranging only non-negatives value so that the spreads of the right of the mean one cancel the left. By using expectation, we are weighting of the high probability values more than low probability values. Properties of variance. There are exactly the same as the district cases. If x and y are independent, then variance of x plus y is equal to variance of x plus variance of y. For constant a and b, variance of ax plus b is equal to a into 2 variance of x. Theorem. Variance of x is equal to e of x square minus e of x whole square. So that e of x square minus mu square. For properties 1, we are using of property 1 x and y independent then. So carefully requirement of x and y are independent. Then property 3 gives a formula for variance of x is easier to hand calculations. The proofs of properties 2 and 3 easily indicator to the direct cases. We will not give them here. Here is a small numericals of properties related. Let x and let x is equal to f of x to find out variance of x and summation of x. So here solution e of x is equal to integration of 0 to infinity x into lambda e power lambda x dx. So that e of x is equal to 1 upon lambda. Then 1 upon x square is equal to 0 to infinity x square into lambda e power lambda x dx. So 2 by lambda square. So after using the property, variance of x is equal to e of x square minus e of x whole square. So e of x square is equal to 1 upon lambda. E of x is equal to 1 upon lambda and e of x square is equal to 1 upon lambda square. So 2 by lambda square minus 1 by lambda whole square. Then 2 by lambda square minus 1 upon lambda square. After the calculation, variance of x is equal to 1 upon lambda square and summation sigma x is equal to 1 upon lambda. Variance of x is equal to 1 upon lambda square and sigma x is equal to 1 upon. This numerical is related by properties of variance. Then continuously random variables numerical. Let x be a continuous random variables with f of x is equal to 4x cube and 0. Here right side 4x cube 0 0 less than x less than 1 and 0 is equal to otherwise. So we'll find p of x less than or equal to 2 by 3 less greater than or equal greater than 1 by 3. So calculate the numericals. So we have formulas. After using of formulas, p of x less than or equal to 2 by 3 x greater than 1 by 3. So p of 1 by 3 less than x less than 2 by 3 divided by p of x greater than 1 by 3. So using of integration formula, so integration of 1 by 3 to 2 by 3 4x cube by dx by 1 by 3 to 1 4x cube. So after the calculation, the values of 3 by 16. Thank you.